मेरे पढ़ाकू बच्चों, एक बार फिर से आ गए हैं हम 3 डायमेंशनल ज्योमेट्री का सबसे इंपॉर्टेंट पार्ट लेकर के, प्लेन। प्लेन ऐसा इंपॉर्टेंट टॉपिक है जिसपे सारा कुछ जुड़ा हुआ है। इट मीन्स स्ट्रेट लाइन, नॉर्मल, प्लेन एंड डिफरेंट फॉर्म्स, especially for the competitive exams and the question carrying 4 marks or 6 marks. So be careful, be cautious and learn each and every concept step by step. First we are starting with the normal form of the plane. Suppose we have in the 3-dimensional O is the origin and ON is the normal to the plane. At any point on the plane, general point what we say P, X, Y, Z and its position vector suppose R, जो हमेशा मानते ही हैं, position vector is R. Now we see that Pn and On are perpendicular. NP vector and On vector are perpendicular. And whenever two vectors are perpendicular, you know very well, the dot product equals to 0. Now the aim is, what is NP? Simple triangle law. Dn plus NP equals to OP. So what is NP? R minus Dn. R minus Dn is NP. On, what is On? D is the length of the normal from the origin, which is always positive. So Dn dot equals to 0. If we expand the bracket, R dot R minus Dn dot n equal to 0. Why? Because D is positive quantity. D is the distance. D never equals to 0. If we expand it, R dot n cap minus Dn dot n cap. And n cap dot n cap is nothing but unit. So this form R dot n cap minus D is said to be the normal form or standard form of the plane. Correct. Suppose we have a 3-dimensional project. This is the plane and this thread is the normal. 0, 0 is here. Now what we see, this thread is nothing but Dn. If the length of this thread is suppose D and unit vector, the direction is n cap, then it is said to be Dn cap. Clear? Any point P on this plane, here P. So this is perpendicular to this thread. Pn is perpendicular to this thread. That's why Np dot On equals to 0. The most important point in the chapter of the plane is, the plane is this paper, then the normal is the most important thing. Suppose this one is the plane, then this thread is the normal. Suppose this one is the plane, then this thread is the normal. This one is the plane, then thread is the normal, and so on. So most important point is DCs of the normal. Now we want to convert this vector form into Cartesian form. How we convert? R means point is XYZ. It means the position vector is Xi plus Yj plus Zk. Clear for R? Dot n cap. Suppose this n cap having DCs LMN. N cap, DCs Li, Mj, Nk, where L, M, N are as usual notation for direction cosines. So here we write Li, Mj plus Nk equals to D. What is the dot product of these two? Lx plus My plus Nz equals to D. This is said to be the Cartesian form or the standard form of the plane. Where? Again listen very carefully. L, M, N are the DCs of the normal. N cap is the unit vector in the direction of normal. And P is our arbitrary point X, Y, Z. Then Lx plus My plus Nz equals to D. And the most important point, this is always positive. Why? Because it is nothing but a distance from origin. Clear? Now the next is, suppose general form in first degree with variables x, y, z given to you. that is ax plus by plus cz plus p equal to 0, where a, b, c are such that a square plus b square plus c square not equal to 0. It means all are not equal to 0. Then ax plus by plus cz we can write as minus p. This we can divide in two vectors. What? The first is r, that is xi, yj, zk dot ai plus bj plus ck equals to minus p. We can write like this. This we can write as, to convert into DCs, because A, B, C are DRs. Here we can write as xi, yj, zk, and here we can write I, bj, ck divide by under root a square plus b square plus c square, that is magnitude of the vector, and here minus p divide by magnitude of the vector. Correct? Now a upon magnitude is nothing but, you know very well, converted into DCs. So a upon this one is L. So we can write it as Li, Mj, Nk. This is as xi plus yj plus zk equals to minus p upon under root a square plus b square plus c square. Now it is converted in the previous general form. A Lx plus my plus nz equals to, this is nothing but our d. जो पहले हमने किया वो चीज आ गई. D is the perpendicular distance from the origin. So if in this general form a plane is given, first you have to transfer this p to right hand side, make it minus p, divide by the magnitude of the vector, that is under root a square plus b square plus c square. We have converted in the previous form, normal form, Lx plus my plus nz, where element are the DCs of the normal. So right hand side is nothing but length of perpendicular from the origin. Clear? So no confusion between the previous form and this general form. Correct? This minus p upon under root a square plus b square, you have to write the distance always in modulus. Correct? So now we come to the second form, that is point normal form. One extra point is given to you on this plane and a normal is given to you. For example, one point extra, that is q x1 y1 z1 given to you, and its normal equation of n is also given to you. It means, suppose normal equation say ai plus bj plus ck, correct, where abc are the drs of the normal, and we know that any line qp is perpendicular to n, that is the dot product, you know, from the vectors equals to 0, since these two are perpendicular. For example, any PQ point on this whiteboard and its normal is here. It means very simple, QP perpendicular to normal. And what is QP? Position vector of P minus position vector of Q, that is R minus R1 dot n equals to 0. What is R? Xi, yj, zk minus what is R1? X1i, y1j, z1k, and dot product with n cap. And what is n cap? ai plus bj plus ck equals to 0. Combine these two. What we are getting? X minus x1, y minus y1, and z minus z1 k. Dot product with ai plus bj plus ck equals to 0. Expand it. A into x minus x1, b into y minus y1, c into z minus z1 equal to 0. Most important form in many questions will use this form. Correct? Now we come to the 3-point formula when only 3 points are given. So what is the small change? The small change is when 2 more points given to you, we can get the normal, because that time normal is not given. This normal is not given. But you know that normal is nothing but the cross product of 2 vectors. Correct? So when we cross product the 2 vectors, what will get? The normal. And 1 point we'll use as it is as r minus r1. So what is the change in a 3-point formula? See that this n vector replaced by, since we have 2 more points, so here it is r and here it is s. With 2 vectors, PR cross product with rs, what will get? The normal. It means this r minus r1 remains same. Dot, we want normal, and normal is nothing but the cross product from remaining 2 vectors, r2 minus r1 cross r3 minus r1, where r2 and r3 are the position vectors of 2nd point and 3rd point. Now you know, whenever 1 dot and 1 cross, it is nothing but the box product or scalar triple product. So we'll use the determinant for scalar triple product. First row, x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. And third row, x3 minus x1, y3 minus y1, and z3 minus z1. So this is said to be equal to 0. This is said to be vector form and it is said to be Cartesian form. Whenever 3 points are given, we have to use this formula. Important thing is, don't learn the formula by heart. Learn the concept. Why this one is perpendicular, why this is normal, why 2 points situated on the plane, how we are getting normal, how we are getting unit of normal, and so on. So if you learn the concept practically, then 3D is very easy for you. But if you just cramming the formulas and this and that, nothing. So my request, go for it practically. Then only you will learn the 3D very easily. Now we'll start exercise 11.3. Question number 1, we have to calculate the DCs and question is given in the general form. It means A, B, C are the DRs. So we have to divide by the magnitude both the side. And what is the magnitude? 4 and 9, 13 and 1, 14. So divide by 14, 14, 14 and 14. So this is 2 by root 14 is L, M is 3 by root 14 and N is minus 1 upon root 14. So tell me, what is the distance from origin? This is the D, correct? And the next question is reverse question. D is given, normal is given, we want to make the equation of the plane. So, and you know the formula, r dot n cap equals to D. But here normal is given, not a unit vector of the normal. So we can convert it. R dot n cap means 3i, 5j, 6k. You have to convert it into n cap. So divide by 9, 25, 36 equals to, D is given to you, origin, distance from the origin 7. Answer is r dot 3i, 5j, 6k divide by 25 and 9 and 36. So this is 45, 50, 60, 70. Or we can write in the Cartesian form, 3x, 5y, 6z equals to 7 root 70. Correct? Next sum number 4th. General form is given. 2x plus 3y plus 4z minus 20 equal to 0, we want to calculate foot of the perpendicular, that is D, from origin. So again, convert like the first sum, equals to 12. Now we have to divide by magnitude of the vector. 4 plus 9 plus 16. 4 plus 9 plus 16. What we are getting? 2x plus 3y plus 4z. Divide by 25, 29. So here again we have to write root 29. And this is nothing but the distance from the origin, perpendicular distance from the origin. What we say? D. Correct? One more. Point and normal given to you. Point is given, so r minus r1 dot n cap equal to 0. N cap is not given. This time normal vector is given. So we can convert it into normal. 1, 1, 1, root 3. This is n cap. And here r minus r1, r minus r1, 1i, 0j, 2k. So we can convert it as a x minus 1i, y minus 0j, and z plus 2k dot with I plus j minus k divided by root 3 equals to 0. So the plane will be x minus 1 into 1, y minus 0 into 1, z plus 2 into minus 1 equals to, this root 3 goes to this side, becomes 0. Final answer is x plus y minus z. Numbers are minus 1 and minus 2 is the general form of the plane. Last is 3-point formula. And 3-point formula, it means using determinant. So first we write x minus x1, y minus y1, z minus z1. x2 minus x1, y2 minus y1, z2 minus z1. Next is x3 minus x1, correct? And you have to solve this determinant and get the answer. So the last step, x minus 1, y minus 1, z, here it will become 0, 1, 1, minus 3, 1 and minus 1. And you know very well how to solve the determinant, is a revision. So x minus 1 into minus 1, minus 1. Then minus y minus 1, y minus is clear. 0 plus 3 and last z into 0 plus 3. Final answer minus 2x plus 2 minus 3y plus 3 plus 3z equals to 0. So arrange it in the proper form. What we are getting, 3 and 2, 5 is the required plane. So now I think you have a full confidence in the equation of the plane, all the 3 forms. Revise it and do it in exercise number 11.3. Basics must be very clear. एक बार नहीं आया 2 बार करिए, 2 बार नहीं आया 3 बार करिए, मगर ये इतना इम्पोर्टेंट टॉपिक है जिसकी इम्पोर्टेंस अगर हम बखान करते रहें तो शायद टाइम कम होगा. यस, तो मिलते हैं अगला टॉपिक लेकर के. तब तक बढ़ते रहिए, पढ़ते रहिए. टेक केयर, गुड बाय.